Welcome back to another warm and sunny day in Thailand. We are now in February. And don't all you people in North America wish you were here instead of freezing your ass off in the polar vortex that happens every year? Anyway, today we're jumping back into our favorite board and we're trying to get actual current and voltage readings working again. But what I need to do is take you down the path of Atmel chip design and the compromises they make and the impact that that has on our circuit. So let's jump in. Okay, here we are in Atmel Start. And I want you to know this has gotten a little flaky on me. When I try and come over here and click on the Atmel Start icon, 2 out of 3 times it crashes Atmel Studio. So I'm not thrilled about that. But let's take a look at the issue. The problem with generalizing things into a nice, point and click kind of solution builder is you lose some of the power of what's actually happening down in the lower layers as you abstract things and come up the stack. Right now we're looking at analog to digital converter number 0, and one of the things you configure is the signals that you're going to be reading. Now we've got a lot of signals we can read here. 0, analog input, 0, 1, strangely enough we jump to 4, 5, 6, 7, 8, 9, 10, and 11. And I'll show you why that happens in a minute. But we also down here, one very important thing that I neglected to understand until very shortly ago was this positive mux input selection and negative mux input selection. These are really the pins where all the action's happening and where the ADC is going to read from. It's going to read from the positive mux, from the positive mux to the negative mux. Regardless of what you select here as possible input signals, Atmel Start really is only focused on what you select over here. And since this is a drop-down list, you can only select one thing. And so for reading current from the ACS device, I want to read analog input 0 to IO ground. This is not helping me also want to read a differential signal between 2 of these pins for reading my voltage. Because what I really want to do is read from these pins for voltage, but Atmel Start doesn't really give me a way to do that, and that means we're screwed. So let's look into that. Okay, now we're back over here in the schematic, and when I designed the board, I naively thought I can read the current sensor with an analog input pin, great, and referencing an IO ground. And then I can read my voltage input on 2 of the other pins and do a differential read between these 2. But as you can see, Atmel Start really doesn't give me a good way to do that. Now, in software, I've done some experiments where I try and use the underlying API to flip between the 2 modes. Single-ended analog input read on this pin, read it, and then quickly change to a differential read between these 2 pins, and then read it. And I get gibberish. Now, I suppose the lack of documentation is not helping here either, and this is becoming my biggest gripe with Atmel. They define all their APIs, and then there's one sentence like, read analog input asynchronous. It'll say, perform an asynchronous input read. Great, but give me some background behind that, especially in the initialization routines or the mode setting routines. Tell me what the implications are. Tell me what else I need to worry about when I want to set it into a certain mode or another. So this is a bottleneck for me. It's not working because both of these pins, all of this group of pins, are mapped to the analog to digital converter number 0. Okay, so let's come over here into the chip definition and see how this all lays out. Now, we're looking at the analog input 0 pin of ADC 0. Great. Now, as we move left, we can see that the symbolic I/O pin name for this thing is called PA03, which then physically maps to our chip pin, analog input 0. It's so easy to get confused. Analog input 0 is mapped to PA02, which is the abstract I/O pin definition across all of the families of the SAM C21. And on my SAM C21E, that maps to physical pin 3. So on the circuit board, if I want to read in software from analog input pin 0 of ADC 0, I wire it to pin 3. Now, you can see if we go down the column of the other input pins for ADC 0, we get 0 and 1, fine. We get to 2 and 3, but if we scroll across, you can see this is blank. That means analog inputs 2 and 3 of ADC 0 are not accessible by any pin on the chip. To actually get to a working pin, we have to jump to pin 5, which is physically in software as analog input symbolic number 4. And then symbolic input number 5 is PA05 is mapped to pin 6, which is exactly what I did on the circuit board. And it may seem weird that I skipped 2 and 3, but that's because they don't physically exist on our chip. Now, let's take a deeper look at the problem. The real solution to the entire headache is for me to start using the included analog to digital converter number 1. It is a completely separately configured analog to digital converter, which is great. I'll use ADC 0 in single-ended mode to read current, reference to I/O ground, and I'll set up ADC 1 as differential and the reading between the two pins that come from the resistor network. And that's great. So let's scroll down ADC 1's pin definitions and see what we can see. Oh, look, 6, 7, 8, 9, 4, and 5 are all blank. I do not have physical access to those pins for ADC 1. So let's scroll down and see what I can find. We're continuing on ADC 1. I have two pins, analog input 10 and analog pin 11, which are mapped to pin 11 and 12 on the chip. Great. So let's keep that in our hand. Let's scroll down, and here we come to the end of the chip. I've got 4 more pins which are not provided in my package. So we are stuck, if we want to do this solution, we're stuck with only 2 pins driving ADC 1, which is great. I only need 2, fine. But we have a domino effect problem because I am currently using those pins on SIRCOM 0, pad 0 and 1 to drive the USB chip on pins 11 and 12, PA08 and PA09. And I'll show you that in the schematic. And here in the schematic, you see PA08, PA09, and 16. It's hard to read these numbers. 16, 15, 14, 13, 12, and 11 I am using to go down to the USB chip right here. So I have no choice but to use these 2 pins, as analog input for the resistor network. That means I have to change the USB chip to be driven by, luckily, the remaining 2 pins of the SIRCOM 0. So let's take a look at that. So I have to switch SIRCOM 0, pad 0 and 1 down to Circom 0, pad 2 and 3, and I hope this is going to work in Atmel Start. And I'm changing from pins 11 and 12 to 13 and 14 to drive the USB chip. And then I'm reading analog input 10 and 11 on ADC1 in differential mode. That should get me what I need. Now, of course, in order to test this, I'm going to have to hack up my circuit board and do some jumpers, and I'm going to have to change the configuration for the Circom 0 definition, and then I'm going to have to build a new definition for ADC1 before I can move forward in my testing software. So let me jump on that now. Okay, I've come into USART 0. We're still on the Circom 0 device, but I'm changing my pins, and you can see that I've got PA11 is now set up for receive, and it's giving me a hint that I should set PA10 for transmit. So that's what I've done, and correspondingly PA10, and it's taken PA11 off the list, which is a little bit of a weird user interface, but hopefully this is going to continue to let me successfully talk to the USB chip. I've also, previous to this, I upped the speed of the port to 115,200 baud because I was getting some glitchiness coming out on the serial port itself with characters being overwritten, but increasing the speed took care of all of that. Okay, just for fun, let's add analog to digital converter number 1 on the fly in Atmel Start. We search for ADC. I want an analog to digital converter. I want to add one to my project. I need one of them. So I say add component. Cross your fingers. And we have an ADC1. So let's scroll down to its configuration, and we want to change this to asynchronous, that is, not asynchronous. Our instance is ADC1, good, we're not going to play with the clock. For analog input 10, we want PA08, and for analog input 11, we want PA09. So it's actually letting me choose the pins I want. Analog input, I'm just checking my notes. Analog input 10, we're mapping to PA08. Analog input 11, we're mapping to PA09. So the tool understands the pins and the symbolic inputs that I have available, which is good. Now, we're sticking with 12-bit, our reference, blah, blah, blah. We do want differential mode, and our analog input 0 pin. Yes, we're measuring the difference. Oh, no, we got to go. Our positive mux is going to be analog input 10, and our negative mux is analog input. Oh, see, here's a problem. It doesn't want to let me do the differential like I want to between 10 and 11. Why am I not allowed to choose pin 11? I don't want IO ground. I don't want internal ground. I don't want any of these pins because some of these don't exist in my chip. And I've selected differential mode. What happens if I unselect that? It's still giving me the same choices.
Now I'm really angry. This is Fargan War.
Here we are in yet another manual, and I found the software definitions for the negative input pins for the ADC, and it's pins 0 through 7 and ground. My physical chip package doesn't even have 0 through 7 for ADC1. It only has 10 and 11. What does that mean? Does that mean that my chips 10 maps to 0 and 11 maps to 1, or there's a hardware limitation that I physically cannot do a differential input on ADC1 of my chip. I don't know. There's nothing that documents this limitation. And I would have to, scrape up the board and run jumpers all over the place and configure the software and run it just to see if it's going to work or not. Now, my other choice is to wire the bottom of the resistor network here to actual physical ground of my board, but I've wanted to avoid that because that means the ground of the motorbike's drive system is going to be the ground of this board, which I've managed to avoid to this point, because that means the ground of this board goes back up to be the ground of, say, the laptop that you've got configured, you've got plugged in, that's configuring potential settings while the system's powered up. And that gives me the willies. Now, the analog sensor for current has a ground, but it's self-contained to the board. It is using a Hall effect system to measure current through here, so there's no physical connection between the power of the bike and coming in here to the board. Now, another alternative I've got is there's another way to control this ADC1, and that is to switching to a sigma delta analog to digital converter style module. Now, it's got two component inputs, input positive on the PA07 symbol and input negative on the PA6 symbol. Stay selected. And then we come down here and we say our voltage reference wants to be our supply. So it's going to compare to a maximum of about 5 volts that I'm driving the board with. We come down here, and our mux input selection is the analog input N0 and P0 pins, which is great because if I come over here, the sigma delta ADC input -0 and input +0 exist on my chip, and they're on pins 7 and 8, which I have not used. They're the pins right next to these pins that I was trying to use for my differential. This may be the simplest thing to try, although I'm not fully up to speed on the ramifications of the sigma delta analog to digital controller or converter. So I've got some things to think about, and I'm going to try and crowdsource some assistance with this. You, gentle viewer, do you think I'm totally off base and I just am not configuring my differential input for ADC1 correctly? Or B, should I tie the negative terminal of the motorbike's power to the ground of this board, and therefore I can do a single-ended reading on ADC1, keeping it separate from ADC0? Or should I change to the sigma delta version on these two unused input pins? And then the last possibility could be just simply to switch the voltage and current inputs from what I'm trying to do. I put voltage on ADC0 in differential mode because it seems to be more amenable to the lowered numbered pins and doing it differentially. Put current over on ADC1 because it has only 2 input pins and seems to really want to reference it against the analog ground. I'm going to go have a strong drink while I upload this. You guys have a think and let me know what your thoughts are, because you guys are really smart and you've helped me out a lot. So get typing away in the comments and tell me what direction I should take this. Thanks so much. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.